Welcome back for another mathematics video. This time we will be talking about fractions.
Fractions are basically numbers that are between whole numbers or integers, and they can be represented by sort of like a divide symbol, where the bottom is the number of total equal pieces, and the top is the selected amount. So let's say we are talking about this fraction. We the way we say it is we can say the number over the other number. So 1 over 2, or in these situations, it's a half. Other fractions, we can call them differently. This will be 3/4. That will be 5/6. But essentially, anything after 4, we just use for example, 5 will be 5th, 6 will be 6th, 7 will be 7th, and so on. So anything above that, we usually just say the number over the other. And so fractions are the way we represent it in the picture will be like sort of like this. We have a circle, not a really good circle, so let's try another one. So we had half. That means we would have divided this into 2 equal pieces just by drawing a line down the center, and we select one of them. If the number gets bigger, let's say we want 6 pieces. Well, 6 pieces, we can do something like this. Okay. Drawing a third, a fifth, or fifths, and then 7th, 8th, 9th, 11th, and so on. There is a technique to do that, which I'll show you right now. So first of all, you need a circle. Let's try that one more time. So if it's a third, draw a dot in the center, draw a line from the top, and then you divide those two into two, I guess, roughly the same sizes. And then you can kind of you can do a multiple of it, meaning if I multiply um, the denominator by 2, and by 3, and by 4, I'm just dividing each piece separately. So if I do 6, then I'll divide those by 2 again. If I were to do 9, then I would, instead of this line, I would have that line. So actually, let's do this. If it's 1 over 1, if it's a ninth, then I would divide like that, right? And if it is a 12th, I believe, a 12th would be, so a third, a 6th, 9th, and a 12th. So that's just half more, right? So like I split that in half. I split that again. That will be essentially a 12th. Okay. For even, well, for multiples of 2's, let's say a half, quarter, and then an eighth, and so on. It's just simply like that, and then like that, and then an eighth would be like that, and then I just keep dividing each piece for 1/16 and 1/32, and so on. So now, how do we compare fractions? Well, there are only 2 conditions where you have, let's say, the denominators are the same, And well, now, so in a fraction, let's say 3 over 4, this top number is called the numerator, starts with an N, and then the bottom starts with a D, it's the denominator, sort of like Terminator. Okay, now when we're comparing fractions, there are two ways to do it. Okay, well, there's actually a third way, but that way is more difficult. So if you have, let's say, the denominators are the same, and then there's one where the numerators are the same, right? But the denominators are different. So if the denominators are the same, it means that the pieces are the same. So we want to draw an 11th, so I need 5 more of that. So I want 3 of them, and I want 7 of them. So clearly the one with 7 is the greater one. And this little sign here, so it tells you which one is bigger by the arrow. So the 7 over 11 is bigger because you have more pieces of that same size. Now for the second situation, the 11 are bigger, but then the denominators are different. So that what we're trying to say is I have a third here, and I need each piece is that big, and then this one each piece is that big. So if I both have 11 of these pieces versus 7 of these pieces, then the one with a smaller denominator will have a greater fraction. Okay, so those are the two, I guess, special cases, because you're not going to see that very often.
Now we're going to talk about where both fractions have a different numerator and a different denominator. So for example, 3 over 5 and 4 over 7. How would you determine which is bigger? Well, one way is you make the numerator the same by finding a common multiple. The other way is making both denominators the same by finding a common multiple. So we can do it like this. So we first have to find out what normally we would actually go for the denominators. It makes more sense. But either way is fine. So we can do, so let's think of what the common multiples of 5 and 7 are. So we know that 5, 10, 15, 20, 25, 30, 35, and then I have 40. I have 7, 14, 28, 35, 42, 49, 56, and 63, right? None of these work other than 35 itself, right? So now that, how can we determine a common multiple for any number or any two numbers? So all you have to do is write them next to each other like this. So 12 and 20, let's do one like that. Let's draw like a little L shape here for the division. You want to determine, you want to simplify these or make them like divide both numbers. So you have to find the number that you can divide. So if it's both even, you can divide by 2. So 12 divided by 2 is 6. 20 divided by 2 is 10. And they're both even still. So let's keep doing that. So 6 divided by 2 is 3. 10 divided by 2 is 5. Now I can no longer simplify them because you cannot simply divide 3 and 5 by the same number other than 1. Because if you do 1, the result stays the same. So now this is the simplest form. You take all the numbers outside and you multiply them together. So that will be 4, that will be 12, and that will be 60. So that will be the lowest common multiple. Now for our case, 35 is the bottom, so that we can do it like so. We can make them both the same. Now 5 times 7 is 35, so I need to times that by 7. That makes 21, because 3 times 7 is 21. And similarly, 7 times 5 is 35, so 4 times 5 is 20. So 3 over 5 is bigger than 4 over 7. Now, some places will actually give you a shortcut, but you can't really prove that in your papers or in your exams. It's just a technique, right? And if one asks why it is true, it's, the typical student will not be able to respond to that. So the way to do this is you cross multiply. So 3 times 7 versus 4 times 5. Whichever is bigger is the bigger fraction. So that's 21 and that's 20, so 3 over 5 is bigger. So that's one of the techniques. You can do it just for yourself, and if you really want to show your teacher or your examiner, you would want to do it the previous method we have just gone over. Now, what we want to talk about now is expanding and simplifying fractions. So we've kind of done that just now, but a little bit more in depth. So let's say we have a fraction, let's say a half, okay? You can expand the fraction so that you have more parts, more equal, like more even parts. So like you can do it like this. So if I multiply 2 by 2 and 1 by 2, I get an equivalent fraction, 2 over 4. And it looks kind of like this. You just basically have more equal parts, but the total shaded area is the same. So I can do the same thing by multiplying by 3. That is, or at least 2 times 6, 2 times 3, 1 times 3. I get 3 over 6. So not drawn to scale, obviously. Now you see it's always half, right? I can do that by multiplying by 4. I get 8 at the bottom, 4 on top. 1 multiplied by 4 is 4, 2 multiplied by 4 is 8, and I can keep doing that. So these are all multiples of the original fraction. It's called an expansion. So you want to expand that so you get a bigger number, but the simplified version is always going to be half. Let's do another example. 3 over 5 will be equal to 6 over 10, 9 over 15, and so on. Okay, so this is you have to recognize that you can do such a thing whenever you see a fraction. Two fractions would be equal, because you divide this by 6, I get 2, divide the bottom by 6, I get 3, so I get the same fraction. Now what about the other way? So if I have something like 20 over 24, now it's the same thing, right? I can simplify that by dividing by 2. I get 10 over 12. I can do the same thing again by dividing by 2. I get 5 over 6, and I can't do that anymore, so that is done. Let's say I have 35 over 60, so I divide by 5. I get 7 over 12. Now I can't divide that further. that is the simplest form. Now, so now that we know how to expand and simplify fractions, what we can do is we can take it a little step further. We can start adding fractions, and we start adding fractions by looking at the same denominator if we have the same denominator, that means we're just saying, okay, I have a pi here with divided into 5 equal parts. I have one of them. I want to add two other ones. Then, technically, the answer will be fairly obvious. I should get 3 equal parts of a pie with 5 equal pieces. So I just add the top. The bottom stays the same. The bottom always tells you what's the total pieces in that whole. Right? I can do the same with subtraction. So let's say I have 6 over 7 minus 3 over 7. I should just subtract the top. I get 3 over 7. Now what happens if the denominators are different? Let's say I have a half. I want to add a quarter to it. How do I do that? Well, visually, what I'm doing is I'm adding half to a quarter. Right? If I put them together, I technically get something like that, sort of like a Pac-Man, right? And just by looking at it, it's hard to tell what the fraction is. But if you divide, if you split it so that both of these pies, the 1/2 and the 1/4, have the same equal pieces, then the total, you can easily tell what the fraction is. So here you see that's divided by 2, divide by 2 further. I can do the same. I can change this pie into 4 equal parts, and then I'll do the same for the final. And then I can clearly tell this is 3 over 4. But we're not going to do that for every question, because you're not going to have time to draw the picture for every fraction. And if it's a fraction that is, like, say, 3 over 17, then you're now going to split a pie into 17 parts, right? And so the quickest way is to convert and change the denominator, or the bottom number, into the lowest common multiple. And as we have done that already, converting into common multiple is we just simply divide by a common factor until you cannot do that anymore, and you multiply everything that's non-zero or non-1, and that will be 4. So the lowest common multiple is 4, so that's why you see this is divided into 4 parts instead. So what I can do here is I have over 4 plus another 1 over 4, so then this will be times 2, and then that will be times 2. So 1 times 2 would be 2 over 4 plus 1 over 4 equals 3 over 4, which is the answer we got here. Now for subtraction, it's the same process. All you do is, let's say I have that 1/2 minus 1/3. Now I find the common multiple, or the lowest common multiple, which is 6, because 2 times 3 is 6. You can't simplify. Now I'm multiplying the bottom number by 3 to get 6, and then the other side by 2. So 1 times 3 is 3, 1 times 2 is 2, 3 minus 2 is 1, so the answer is 1 over 6. Alright, now multiplying and dividing fractions is a little different. First of all, you don't have to convert the denominators the same. So if I have 2/3 multiplied by 1/2, this is not what you should do. That's not what you should do. That's the wrong way of doing it. The correct way of doing it would be, you have 2 ways, right? You either multiply horizontally, and once you have the answer, you simplify the answer to the simplest form. So 2 times 1 is 2, 3 times 2 is 6, and like you see that you can further divide that by 2, so I get 1 over 3. Now the simpler way to do this would be to simplify beforehand. Now I'll show you. You can this is the same as 2 times 1 over 3 times 2, and you see this would be the same as 1 times 2 over 3 times 2, right? And if I really wanted to, I can break that up again. I get 1 over 3 times 2 over 2, and that is just equal to 1 because I have 2 wholes. Out of 2 wholes, I get 1 whole. So I have 1/3 times 1 equals 1/3, and anything times 1 is itself. So I don't actually have to do all this stuff. I can just do it here. I can just simplify by divide by 2, divide by 2. 1 times 1 is 1, 3 times 1 is 3. I can do it like that. For division, it's a little different too. Let's say I have 2 over 3 divided by, let's say 4 over 5. Okay, so when you're dividing, what you need to do is you need to change the sign into a multiplying sign, and then you take the reciprocal, which is you flip the fraction. So the 5 now goes on top, the 4 goes in the bottom, and then you do the same process. You can simplify, and then when you cannot simplify further, you multiply them out. So I get 5 over 6. Why? Okay, many will ask, why do you have to flip? Okay, so here is a very simple question, or answer to the question. So let's say I have 3 divided by 2. Okay, what I'm doing is I have 3 wholes, and I want to split into 2 equal groups, and the rest will be well, basically I want to group them, right? Now let's say I want to split them into A and B. Okay, so this would be A, this would be B, and then I have 1 whole left, right? How can I split 1 into 2? Well, I can divide that. Half of it goes to A, half of it goes to B. Now this will be 1.5, and then these will be 1.5. So I have 1/2 here and 1/2 here, right? So the answer would actually be 1/2. But if you think about this, I don't see 1/2 here, right? Oh, actually, sorry, this is 1.5. So this is actually called a mixed number, which is a whole number mixed with a fraction. So it has both wholes and fractions. So 1.5. This is 3 divided by 2. There's no way you can see it. So what happens to this is you have 3 divided by 2, right? So you have 3 times 1/2, because 2 is just 2 over 1, because you have 2 whole pieces. Each one is not cut into pieces, so it's always over 1. So 2 over 1, you flip that, you get 1 over 2, and 3 is 3 over 1. So you have 3 times 1 is 3, 1 times 2 is 2, and then now I can write this as 2 over 2 plus 1 over 2, and that is just the 1 whole, and that will be the other half. So I can write them next to each other, and that will be the same answer. So dividing is you take the second number, you make that into a fraction, and then you take the reciprocal, or meaning you flip the top number and the bottom number, and then you make that a multiplication problem, and then you can solve it as a multiplication problem. So that's it for this video. It's just very basic introductory to fractions. Next time we'll go into more detail. We'll go into other types of questions that are more complicated. I'll see you there next time. Make sure you subscribe and follow and like the channel, like this video, and we'll see you next time.